Welcome to your weekly introduction video. This week we're going to learn about angles, and specifically angles in polygons. Okay, I'll explain exactly what is meant by a polygon in a minute. Okay, but first of all, I want to just see whether you can remember some basic angles facts. Okay, so I want to stop the video and see if you can calculate these missing angles. You can use a calculator or do it without if you want to just test your mental maths abilities. Okay, stop the video and have a go. Okay, so for the first one, what you've got to do is recognize the rule that all the way round is 360 degrees. 360 degrees in a circle. So to find C, all we need to do is do 360 minus 110. Let's write this down. C is equal to 360 minus 110 minus 63 minus 50 minus 75. So let's just do that on the calculator. Okay, and that will tell me that C is equal to 62 degrees. Okay. Question 2, easy enough as well. We can actually say that C plus 38 plus 85 is equal to 180. We can write it in the form of an equation, okay, because the sum of angles in a triangle is 180 degrees. 38 plus 85 is equal to 123. So C plus 123 equals 180. Okay, take 1, 2, 3 from both sides, and we're left with C being equal to, what would that be, 57 degrees. Okay, so again, you see here how we can write things as equations again. Okay, honestly, if you just look at maths in that way, it really is going to unlock a lot of problems for you. It's going to make life really easy. We can do number 3 as an equation as well. It's a quadrilateral, and we should know that the sum of angles in a quadrilateral is 360 degrees. So we're going to do x plus 60 plus 60 plus 120 should be equal to 360 degrees. Again, we have an equation. I don't need it. Don't need a calculator for this. X plus 240 is equal to 360 degrees. So take 240 from both sides. Then we're left with x is equal to 120 degrees. Okay, nice and easy. Number 4 is all about those parallel lines again. Parallel lines. We can see that this line is parallel to this line. So straight away, I can see that B is equal to 72 degrees because they are corresponding angles. We've got this kind of F shape. This F. When we see an F, we've got corresponding angles, okay? I can actually see that D, let's just get the right colour, D is equal to also 72 degrees, but this time because we've got a Z shape, so they are alternate angles. Okay. So what else can we say? We can say that C is equal to 108 degrees because D and C are on a straight line. Straight line's 180 degrees. A is also 108 degrees because it is vertically opposite to C. Okay, so all those rules you need to know. Now E is also 108 because it lies on a straight line with the 72. F is 72 because it's vertically opposite to the 72. And again, G is also 108 degrees. Okay, so hopefully you knew all that. Okay, remember to submit your answers on the task. Take a picture of your work. Okay. Right, now, so we're going to move on to something a little bit more tricky. We're going to talk about polygons. Now, what is a polygon? This is a polygon. This is not a polygon. This is a polygon. This is not a polygon. This is a polygon. This is not a polygon. Okay? Hopefully you can now understand what is meant by a polygon. So stop your video and see if you can write down what is the definition of a polygon. Okay? Hopefully you wrote something along the lines of this. A polygon is a two-dimensional shape with any amount of sides. Any amount of sides. Okay? These are not polygons because they're not a shape. Okay? They don't connect. If I connected it up, now that would be a polygon. Okay? And a polygon could have any amount of sides. Any amount of sides at all. Okay? So I could even do a pentagon, which would be like that. Okay? That is what we refer to as a polygon. Okay? So here I've got some examples of regular and irregular polygons. So on the left-hand side are regular polygons, and on the right-hand side are irregular polygons. Now again, I wonder if you can stop the video and write down a definition of what a regular polygon is. Okay, hopefully you wrote something like this. A regular polygon is a polygon that has equal side lengths, and I bet you didn't think about this, and equal interior angles. Interior angles. So what I mean by that is this angle is the same as this angle is the same as this angle. This angle is the same as this angle is the same as this angle is the same as this angle. Okay? All the angles in a regular polygon are equal. In an irregular polygon, the side lengths might be different and the angles within the polygon also might be different. Okay? So we need to understand what a polygon is, and we need to understand what a regular polygon is. Okay? And we need to understand what is known as an interior angle and what is known as an exterior angle. So all polygons have both interior and exterior angles. So here is a pentagon. Now the interior angles everybody knows. Okay, that's an interior angle. There's an interior angle. There's an interior angle. There's an interior angle. And there's an interior angle. Now we always have the same number of interior angles as the number of sides of the shape. Okay, and everybody knows what an interior angle is. It's the exterior angle that they get wrong. Okay. This is an exterior angle. Lots of people think that it's this all the way outside, but it's not. Okay? An exterior angle is made from creating a line from the side beyond the interior angle, and then it's this angle here. That's an exterior angle. And so what you can see, because it's made from a straight line, an interior angle and an exterior angle are linked. They always sum to 180 degrees, as it says there. That's a very, very important formula, so I suggest you write that down. Okay, an interior angle plus an exterior angle is always equal to 180 degrees. So, hopefully you know what a polygon is, you know what a regular polygon is, you know what an interior angle is, and you know what an exterior angle is. Okay, if you don't know any of those things, better come on the call and ask me, because you're not going to be able to do anything unless you understand the definitions. Okay. Now, what is the name of the... Stop the video and have a go at these questions yourself, okay? Right, okay, what is the name of this shape? Well, okay, I bet a lot of you said it was a triangle. Well, actually, these dashed bits here tell me that they are the same, the side lengths are the same. So actually, it's an equilateral triangle. You can be more specific. An equilateral triangle, all of the side lengths are the same. So is it regular? Yes, it is. Okay? Equilateral triangles are always regular. And they have an interior angle, okay, always of 60 degrees. Always has to be the case. Okay? What's the size of the exterior angle? It's not 300 degrees. What we need to do is extend the line, and we can see that that would be 120 degrees. So there's 60 degrees for interior, 120 degrees for your exterior. Okay? Now, what about the sum of interior angles? Well, let's add them all up. 60 plus 60 plus 60 is 180 degrees. What about the sum of exterior? Well, that would be, there's another exterior here, which would also be 120. And there's another exterior here, which again would also be 120 degrees. So adding up those three exterior angles, there's always the same number of exteriors there are number of sides. Adding them all up, I can see it's 360 degrees. Okay? What about this one? Stop your video, have a go. Okay, hopefully you can see that it's a square. Okay, is it regular? Yes. Interior angles of a square, 90 degrees. That's hopefully not too difficult to understand. Exterior angle, also 90 degrees. Okay, and there, oops, sorry about that. And there are obviously 4 of them. Each of the exterior angles is 90 degrees. So if I add them up, the sum of the exterior angle is 360 degrees, but also, so is the sum of the interior angles, the sum, if I add them all together, 360 degrees, okay? Right, Pentagon. I've already told you the name of the shape. Stop your video and have a go. Okay, it's a pentagon. Is it regular? Yes, it's regular, because all the sides are the same length. Those little dashes tell me that. Okay, now we have to think, what are the sizes of the interior angles? Now I'm going to let you in on a little fact, okay? There's a pattern. A triangle had 180, okay? A square or a quadrilateral had 360. Now why is that? That's because I can actually split it into 2 triangles. Okay, two lots of 180 is 360. Well, a pentagon, I can split into 3 triangles. 1, 2, 3 triangles. Okay? So if each triangle is 180 degrees, then the sum of the exterior angles must be 540 degrees. So how can I know what the size of one interior angle is? Well, if they all add up to 540, and there are 5 of them that are all the same size, I can just do 540 divided by 5, and I'm told that's 108 degrees. Okay? Exterior angle, well, I know that interior plus exterior is 180, so it must be 72 degrees. Okay, it must be 72 degrees. And if I then do all of them, Well, it's irregular, so they're all the same. They're all 72. So 72, and there are 5 of them. 72 times 5 is 360 degrees. Notice the sum of exterior angles is always 360 degrees. Okay? Now, in the task, I have given you a Word document, okay, which looks like this. Okay? And what I want you to do is try and fill this in yourself, okay? You're going to fill in what we already know. So we've got a triangle, we've got a square, we've got a pentagon. We know the number of sides, 3, 4, 5. Okay, and we talked about splitting them into triangles. So there was one triangle for a triangle, obviously, 2 triangles for any quadrilateral, 3 triangles for a pentagon. Okay, a triangle's sum of interior angles is 180, a quadrilateral's is 360, a pentagon's is 540. Okay, the interior angle of a triangle of a regular polygon, remember if it's irregular then it's not necessarily 60. Then it was, for a square it was 90, and for a pentagon it was 108. So the size of one exterior angle for a regular one of these polygons was 120, 90, 72. And it didn't matter what shape we were talking about, the sum of the exterior was always 360. Okay? Now what I would like you to do in the Word document is fill in for a 6, 7 and 8-sided shape. Okay? Fill in the rest of this information. And then now here's the clever bit. Can you tell me what these things would need to be for an n-sided shape? So what I would call an enagon. Because if you can do that, you are going to be able to generate some formulas which we can then use to help us generate equations which are easy to solve, so it will help us solve a lot of problems. So you can definitely fill in these rows very, very easily. This might be a bit more challenging. Okay, but let's see what you come up with. Okay, so stop the video, go to the Word document, and fill that in, and then you need to submit your Word document when you complete the task. Okay, so I can have a look. Okay, so hopefully you've done that. Now, hopefully you know the names. So we've got triangle, square, pentagon. 6-sided is a hexagon. Then we've got a heptagon and an octagon. Okay? Look at what's going on here. Number of sides for a hexagon would be 4. Okay, so then for a heptagon, logically it would be 5. For an octagon, logically it would be 6. Notice how the sum of interior angles is increasing by 180 each time. So that's going to be 720, 900, and 1080. Okay, interior angles are going to be the sum of the interior angles divided by the number of sides. So for a hexagon, it will be 720 divided by 6. That's 120. Okay, for a heptagon, it would be 900 divided by 7. Well, you're going to get a funny number there. It's going to be about 128.6 to 1 decimal place. For an octagon, 1080 divided by 8 is going to be 135 degrees, okay? Exterior angles, all we need to do is take the interior away from 180. So that's going to be 60. That's going to be 51.4. That's going to be 45. And it didn't matter what shape, the sum of exterior was always 360 no matter what. Okay, so now here was the difficult bit. Can we generalize this for an enagon? Well, let's do an easy win first. Let's do the sum of exterior angles. Didn't we already say that it didn't matter what size your polygon is, the sum of exterior angles is always 360 degrees. So for my entagon, it's always going to be 360. Okay? Now what about the number of triangles? Look at the relationship between the number of sides and the number of triangles. It's always 2 less than the number of sides. So that's going to be n minus 2. Okay, it's going to be n minus 2. Now, what about the sum of interior angles? Okay, notice how 180 is 180 times 1. I'll write it over here, 180 times 1. Look at the square, it's 180 times 2. Pentagon, 180 times 3. 180 times 4. It's always 180 times the number of triangles. Now, since the number of triangles on an entagon is n minus 2, it must be 180 times n minus 2. And we use brackets for that. Okay? What about the interior angle? Well, the interior angle, all we did was do the sum of interior angles and divided it by the number of sides. For example, for a hexagon, I did 720 divided by 6. So all it's going to be is 180 lots of n minus 2 divided by the number of sides. Okay? Now, exterior angle, there might be a couple of answers here that you could have done, but I think the easiest way to do that is recognize that the exterior angle is 360 divided by the number of sides. For example, 360 divided by 3 is 120. That's how you get your triangle. 360 divided by 4 is equal to 90. That's how you get your quadrilateral. So all we need to do is do 360 divided by the number of sides to get my exterior angle on an entagon. Okay, so 360 divided by n. Okay, so hopefully that makes sense. If any of it doesn't, you do need to contact me, because you need to understand where these formulas come from, and, I'm sorry to say, you need to remember them as well. You need to remember them. So here are the important formulas. Do you know what? I'm just going to write them differently. They've got them written in a very stupid way here. So sum of interior is equal to 180 times n minus 2, where n is the number of sides. Okay, one interior angle in a regular polygon is 180 times n minus 2 divided by n. Okay, and sum of exterior is always 360, no matter how many sides. And one exterior angle is equal to 360 over the number of sides, over n. Okay, so make sure you've got those formulas written down, you understand where they come from, and then we're going to look at using these formulas in part 2. Okay, so this video will stop, there'll be a part